I'm going to do the next, topic from aldehyde ketones and carboxylic acid. And that very next topic, I need to do is about the structure of the carbonyl group, right? So this is, going to be a, short one, but still going to be very important one. In the next section, I will talk about the preparation of the aldehyde ketones and carboxylic acid. But right now, that's a short topic, and that's called structure of carbonyl. So what the structure is, this is what the structure is, right? Now the question is, as you can see, the hybridization of carbon is sp2, right? The hybridization of the carbon is sp2, where if you expand the structure, what you see that there is a pi bond here, and that pi bond is formed. Let me show you something. So this is the actually overlapping diagram for this carbonyl group. Now the question is, what are the significance of this group? So this is your orbital. This is your orbital overlapping diagram, right? Where this one represent to a sigma bond and this one represent to a pi bond, right? Now the very important thing is that this bond is quite a polar one. This bond is a quite polar one. Why? Because the dipole moment of this particular functional group is towards the oxygen, so it has a partial negative here, and the carbon itself has a partial positive here, right? So this is exactly a polar group, right? Now, if it's polar group, this must be then highly reactive. So if it's polar, therefore highly reactive. Now the question is, what are the resonating structure where? So let me show you something. What happened, you do know that there are already two lone pairs. So if you try to make a shift of this pair of electron, you get an structure where now carbon is losing the electron, so it develops a partial positive charge. It develops a positive charge, while oxygen has gained a pair of electron, so it develops a negative charge. So carbon act as a electrophile, or I should say electron pair deficient. Electron pair deficient, while this oxygen act as a electron rich, right? Electron rich. Being electron rich, this is a Lewis base. Being electron rich, this is a Lewis base, and being electron deficient, this is Lewis acid. Right? Two of the very important thing I need to tell you is that what is the conclusion about this group? Conclusion. The first thing, it is polar. Second thing, highly reactive. Third, it has a hybridization of sp2. It has hybridization of sp2. Now there is something important here. Now since the hybridization is sp2, what that means? That these three atoms, whichever going to be oxygen, this one and this one, they are actually on a trigonal planar geometrical structure. So what is the geometry coming out to be? The geometry is trigonal planar. trigonal planar. What that mean, that the bond angle around each, let me draw it again, that the bond angle around each is going to be 120. This is also 120, this is also 120, and similarly this one is also 120. 120 degree, 120 degree and 120 degree. So these are some of the very important thing about the carbonyl group structure and the conclusion based on that. We will talk about remaining thing in the very next time. But with this, I'm just finishing this right here. I would say thanks for watching.